uniform rigid bar with negligible mass is 1.2 meters long, and the bar is pivoted at point P right here. 3 coplanar forces act on the bar as shown, and they tell us all the story about all the force. So the bar experienced a resultant moment 6 Newton meter in the clockwise direction. You know, clockwise means the rod will turn. There is a net moment due to all these forces. But they ask us what's the magnitude of F. So let's look at, firstly, okay, there's a pivot right here. What is the moment due to each of the force that we already know? The first one is a 16 Newton. 16 Newton is going to pull this bar this way, right? It's going to cause a clockwise rotation. So I think we'll put a note here that this is clockwise moment or clockwise torque, which will be the force times distance. So 16 times 0.3. Okay, and let's find the value. That will be 4.8 Newton meter. All right, next. Then you have the 20 Newton. Oh, this one, remember everything is rotating around the pivot point. So this will try to pull and fight the other force. It is going anti-clockwise. So this, I think we'll put a note. Let's make it pinkish. How about that? Anti-clockwise. Torque, 20 times 0.3. That value will be 6.0 Newton meter. Okay. And then we have force F, which we do not know what it is. That's why we have to solve lah. So we need to, firstly, resolve it to be perpendicular to the rod, because all these equations are torque equals the force times distance. Actually, you either must have perpendicular force times distance or force times perpendicular distance. In this case of this kind of rod, it's usually easier to resolve the force. So you have to resolve the force to be in this direction. What part of F is in that direction? Or you could just drag it out to this side and you already have a nice triangle. It's the same, either side. So this will be F opposite hypotenuse sine. F sine 30 is the force that you want to use. That is perpendicular to the rod. Okay, let's add up all the moments together. Clockwise, anti-clockwise. Oh, by the way, this one is clockwise. It's going to try to pull the bar this way. Still clockwise. Alright, add up. So net or resultant moment of 6 means after you add all these 3 forces moment, you should get the answer. So the net moment, usually we use this symbol, is 6 equals to... There's one thing you need to be careful of. Moment actually is the direction and sign also matter. So for this case, since the resultant moment is 6 in the clockwise, I'm going to define anything that is clockwise as positive, anything that is anti-clockwise as negative. Like how in any kind of vectors, you must define up is positive, down is negative, those kind of things. We do the same here. So you have positive 4.8, negative 6.0, and this one is positive lah. Whatever that value is. Okay, let's write it out now. So we have 4.8. You need to minus 6.0. And you need to plus F sine 30 times the distance to the pivot. Be a bit careful, the distance to pivot is all the way here. So in total, that's about 0.9. So we're going to write 0.9 down. And let's calculate the force, F. 16 newtons as our calculation. So the best choice we can choose here would be 16 Newton as our moment. Okay, so remember, we see any kind of moment question, stay calm, look at each force. Is it clockwise, anti-clockwise? And then solve accordingly. Okay, so that's all for this question. I'll see you in the next one.